Welcome to the deep dive. Today we're going to take a closer look at a really important figure from the Middle Ages, Leonardo Bonacci, better known as Fibonacci.
Fibonacci, yeah.
I mean, before him, Europe was using Roman numerals, which, as you can imagine, made calculations really, really difficult.
Oh, absolutely, yeah. Trying to do any sort of complicated math with those, X's and V's and stuff, it's a nightmare.
It's like trying to build a house with just a hammer, you know what I mean?
Yeah.
You need the right tools for the job. And he essentially gave Europe those tools, centuries before calculators or anything like that even existed.
It was a huge leap forward, really changed the game. And that's what we're going to try to understand in this deep dive today. You know, how revolutionary his work truly was for how people calculated, how commerce worked, how Europe functioned, really.
Right, right.
And of course, we can't talk about Fibonacci without talking about the famous Fibonacci sequence. It's fascinating. It's got this enduring legacy, and we're going to explore all of that.
Yeah, the rabbit problem.
Yeah,
Right.
that's the one. So we've got a great excerpt here that really gets into his life and all his amazing contributions.
Perfect. Okay, let's start with the basics. So Leonardo was born around the year 1170 in Pisa, Italy. And his family wasn't just any family, right? They were a prominent merchant family.
Oh, yeah. Very well connected, very successful in the trading world. And it's important to remember that, being a merchant back then, it wasn't just about buying and selling. It was about understanding numbers, calculating profits, understanding exchange rates, all that stuff. It was a very mathematical profession.
Right. And his father was a customs official over in Bugia, which is in modern-day Algeria.
Yeah.
Why was that location so important?
That's a key part of the story. You see, Buju was a melting pot, a crossroads of different cultures. And crucially, it was a major center of Islamic scholarship, particularly in mathematics. So Fibonacci wasn't just born into a family with a knack for numbers. He was exposed from a very young age to a much more advanced mathematical world than what existed in Europe at that time.
So it wasn't just learning basic math. It was like being thrown into the deep end of, I don't know, like advanced calculus or something.
Exactly. And
Mm.
he was taught by these brilliant Arab mathematicians who had inherited this rich tradition from India, the birthplace of our modern number system. So he was immersed in these Indian and Arabic number systems and the sophisticated methods they use for calculations.
Wow, talk about a head start. And, his travels were also really important to his development as a mathematician. I mean, he went to Egypt, Syria, Constantinople, Provence. These weren't just quick trips, right?
Oh, not at all. These were extensive journeys across the Mediterranean. And think about it, this was a time when knowledge was spread through travel, through personal interactions. So these trips were like his university, He was soaking up everything he could. He was gaining this deep understanding of algebra, geometry, and all these different numerical systems he encountered along the way.
It's like a chef traveling the world, learning different cuisines and techniques.
Exactly. He was like a mathematical gourmand, sampling the finest mathematical delicacies from each region. And these experiences, they were absolutely foundational to the groundbreaking work he would later produce.
And that brings us to his most famous work, Liber Abaci, or the Book of Calculation, published in 1202. Now, this wasn't just a math textbook, right?
Oh, no, no, no. This was a bombshell. Just imagine a world struggling with Roman numerals. Trying to multiply x78 by lxxx.
I mean, I could barely read Roman numerals.
Exactly, it's a nightmare. And then suddenly someone introduces these simple digits, 0, 1, 2, all the way to 9, along with this concept of place value, where the position of a digit determines its value. It was a revolution.
It's hard to imagine doing anything without zero now.
Absolutely. Try balancing your checkbook without it. But back then, it was a brand new concept. And Liber Abaci didn't just introduce these Hindu-Arabic numerals. It laid out their power, their efficiency, their elegance, really. It was like a user manual for a whole new way of thinking about numbers.
So it wasn't just theory, it was all about practical applications, particularly for commerce and banking, right?
Exactly. That's what made Liber Abaci so revolutionary. It was a practical guide for merchants, bankers, anyone who dealt with numbers. It's almost like he was providing the blueprint for a brand new financial system. And the timing was perfect, because Europe was experiencing this economic boom, this growth in trade, and they desperately needed better tools to manage it all.
And this was in the 13th century, right? So imagine the complexity of trade back then, with all these different currencies floating around, florins, bezants, denarii, dirhams. It must have been a nightmare.
It was, and Liber Abaci tackled this head on. It's filled with hundreds of specific examples, real-world scenarios designed to help merchants navigate this complex financial maze. I mean, the excerpt we have here gives this fantastic example. It says, if one bezant equals 15 denarii in Venice and 12 denarii in Pisa, how many bezants do you get for 240 denarii in Pisa? And it walks you through, step by step, how to solve it.
So it wasn't just about memorizing numbers. It was about understanding the underlying principles, the logic behind it all.
Exactly, and that's what made it so powerful. These weren't abstract puzzles, they were the real-life challenges merchants faced every day. Fibonacci was giving them the tools to calculate exchange rates, to deal with barter systems, to convert weights and measures for different goods. It was a practical toolkit for success in the medieval marketplace.
So basically, he was giving them a competitive edge.
Absolutely. And it wasn't just basic arithmetic either. He also tackled more advanced concepts like profit and loss. I mean, can you imagine trying to run a business without understanding your profit
I
margins?
mean, you'd be going in blind.
Exactly. But before Fibonacci, a lot of European merchants were doing just that. So he introduced the tools they needed to calculate their profits accurately, their investment returns, even the accumulation of interest. And this was revolutionary because interest, that seemingly simple concept, is the foundation of modern banking and finance.
Right. And he even had examples like, if 100 denarii are loaned at 5% annual interest, how much will be owed after 3 years?
Exactly. He was laying the groundwork for understanding how money could grow over time, how investments could generate returns. It might seem basic to us now, but back then, these were groundbreaking ideas.
So from currency conversions to profit calculations to interest, it's like he was creating the building blocks of modern finance.
Yeah.
And he even addressed, the challenges of business partnerships, like how to divide profits fairly.
Yes, he tackles that too.
Yeah.
What happens when you have multiple investors putting in different amounts of capital? How do you divide the profits fairly? The example he gives is three men invest 100, 200, and 300 denarii. The profit is 180 denarii. How should it be fairly divided? And he lays out the method for calculating that. It's an early form of what we now call equity distribution, a fundamental concept in corporate finance.
That's amazing. He was really ahead of his time. And while double entry bookkeeping came a bit later, Fibonacci's work really set the stage for it, right?
Absolutely. You see, the Hindu-Arabic numeral system, with its place value and that crucial zero, made systematic record-keeping possible. Imagine trying to manage a complex ledger with Roman numerals.
My head hurts just thinking about it.
Exactly. But with this new system, calculations were easier, you could track balances more efficiently, and you could create more transparent financial documentation. It was the foundation for the sophisticated accounting systems that would shape the modern business world.
So he gave Europe this new way to do math, a new way to run their businesses. But he's also hugely famous for something a bit more, well, rabbit-related.
Ah, yes, the famous rabbits, the Fibonacci sequence. It all started with a seemingly simple problem posed in Liber Abaci about how quickly rabbits could reproduce.
Right, the rabbit problem. Something like, how many pairs of rabbits will you have after a year if you start with one pair and they reproduce every month?
Exactly. How many pairs of rabbits can be produced in a year from a single pair if each month each pair begets a new pair, which from the second month on becomes productive?
So the answer to this fluffy conundrum is this sequence. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. And the rule is each number is the sum of the two numbers that came before it.
It's beautifully simple yet incredibly profound. And what's truly remarkable is how often this sequence, which started with these imaginary rabbits, pops up in the most unexpected places.
It's like it's embedded in the fabric of the universe or something. I mean, you see it in the spiral patterns of seashells, the arrangement of seeds in a sunflower, the scales on a pine cone, even the structure of a hurricane. It's everywhere.
It really is. It's like nature's secret code. And it's not just pretty patterns either. The Fibonacci sequence appears in the growth patterns of plants and animals, the branching of trees, the arrangement of leaves. It's this fundamental pattern that seems to govern growth and development in the natural world.
And it has this fascinating connection to art and architecture as well, this concept of the golden ratio.
Ah, yes, the golden ratio. It's this irrational number, approximately 1.618, that's closely tied to the Fibonacci sequence. You see, as the sequence progresses, the ratio between consecutive numbers gets closer and closer to this golden ratio. And for centuries, artists and architects have used this ratio to create proportions that are considered inherently pleasing to the eye.
Like the Parthenon in Greece or Da Vinci's Vitruvian Man.
Exactly. Those are classic examples, and it goes beyond just visual appeal. The golden ratio and the Fibonacci sequence are believed to play a role in musical harmony, in the structure of galaxies, even in the proportions of the human body. It's this profound link between mathematics and the natural world.
And even in modern times, this sequence that started with imaginary rabbits is being used in things like stock market analysis, computer algorithms, and even artificial intelligence.
Exactly. It's used in technical trading in what's called Fibonacci retracement to predict potential levels of support and resistance in stock prices. And in computer science, it's used to design efficient algorithms for searching and sorting data. It's a sequence that keeps on giving.
It's mind-blowing. So we've covered Liber Abaci, the rabbits, the golden ratio, but Fibonacci wrote other important works too, right?
Oh, absolutely. While Liber Abaci was his most famous, he didn't stop there. He wrote Practica Geometriae, which focused on practical applications of geometry, things like land surveying, measurement, and construction. He also wrote Liber Quadratorum, which delved into the fascinating world of number theory, exploring the properties of square numbers. And then there was Flos, which tackled some really challenging algebraic problems, including methods for solving cubic equations.
Wow, so he was really pushing the boundaries of mathematical knowledge. It's amazing to think what the world was like before his work. But the source did mention that the adoption of his ideas wasn't immediate, that there was some resistance.
Oh, yeah, that's a really important point. Big changes, especially ones that challenge the status quo, they rarely happen overnight. And shifting from Roman numerals to this new Hindu-Arabic system was a huge change.
It's like trying to convince everyone to switch to a new language.
Exactly. So there was resistance. People were comfortable with the old ways. They didn't see the need for something new. Some guilds, those powerful merchant groups, and even certain governing bodies were slow to adopt these new methods.
But eventually, his ideas did take hold, right?
Yeah.
I mean, we can't imagine a world without the number zero now.
Absolutely. The sheer practicality, the elegance, the efficiency of this new system, it was undeniable. And it was the merchants, the bankers, the people on the front lines of commerce who really embraced it first. They saw the advantages firsthand, the ease of calculation, the reduced errors, the increased efficiency.
It gave them a real advantage.
Exactly. And then educators started incorporating his methods into their teaching. Renaissance scholars rediscovered and championed his work. And slowly but surely, this system that Fibonacci had advocated for, it spread throughout Europe, and it fundamentally changed everything. It revolutionized commerce, finance, science, engineering. It laid the groundwork for the modern world.
Wow. And his legacy continues to this day, doesn't it?
Oh, absolutely. I mean, Fibonacci is widely considered the father of modern arithmetic in Europe. There are statues in his honor, academic prizes named after him, even financial tools that use his sequence. And his impact goes far beyond just the practical applications. He helped to reawaken Europe to the power of mathematics, to its beauty, its elegance, its ability to explain the world around us.
So, to summarize, Fibonacci was this incredible figure who not only introduced Europe to a revolutionary new way of doing math, but also provided the essential tools that fueled the growth of commerce, finance, and really the modern world.
Precisely. He was a visionary, a bridge between the East and the West, a true pioneer who helped to shape the course of history. And his story reminds us that numbers aren't just abstract symbols. They're powerful tools, and they have the power to transform our lives in profound ways.
It's amazing to think about how something as seemingly simple as a sequence of numbers, starting with those imaginary rabbits, can have such a profound and lasting impact on our understanding of the world. And it makes you wonder, what other hidden patterns, what other unexpected connections are out there just waiting to be discovered? What will be the next Fibonacci sequence that changes the way we see the world? That's something to ponder.
It really is. And for you, our listener, I think the key takeaway here is this. Stay curious, keep exploring. You never know what amazing discoveries are waiting just around the corner.
Absolutely. Thanks for joining us for this deep dive into the world of Fibonacci.
My pleasure.
Until next time.
See you then.